Well, thanks everyone for joining. Brian and I are here today to talk about adapting our open source license practices in the age of LLMs. My name is Tanya Courcey. I have been at Fidelity for about 18 years, all that time in the legal department, primarily in the intellectual property group. As part of my role, I have had the opportunity to work with and support our open source program office. And over the past year or two, obviously that role has changed a little bit with the advent of LLMs. And so with that, Brian, I'll turn it over to you.
Sure, thank you. My name is Brian Warner. I am one of the Brian Warners in the tech industry. There's also a Brian Warner in Python and a Brian Warner who's an astronomer. I'm not actually even the only Brian Warner at Fidelity. I'm actually Brian Warner 2. So I come from the open source community. I've been Linux Foundation, Samsung, IBM, et cetera. For the past 2.5 years, I've been at Fidelity working on building out our open source program office and our policies. And one of the things that is in our remit is this idea of open source licenses. This is a topic that I really love. It is one of my favorite ones, and specifically this particular topic about how licensing and compliance have changed in the wake of LLMs. And 2 years ago when I took the job, I wouldn't have foreseen that we'd be having this talk. When I took the job at Fidelity originally, open source licensing looked like it was going to be nice and boring. Just another part of the job. Very predictable, and we understand these licenses, and we understand how to apply them, and that was all kind of wrong. So I assume I'm not the only one who would say that LLMs threw some licensing surprises our direction, and there are a few reasons that I say this. First, there's no shortage of LLMs that claim to be open source, but in reality, they're released with some sort of wonky license that isn't even remotely close to the open source definition. Second, licenses on LLMs just work differently. And it's differently from the way that we're accustomed to licenses working in open source. There's a higher propensity for latent licenses or license errors, and they're harder to detect. So this talk is going to be about how we at Fidelity got comfortable with how these licenses on LLMs are different, and then also what's working for us in production. So we don't actually have a lot of time today, so we're going to cover 3 key things. First, we're going to just establish a baseline on how we think the licenses have changed. We'll talk about how LLMs break some of our usual assumptions about how license compliance should work, and then tell you a little bit about how we at Fidelity have actually adapted to this. And we are happy to take questions at the end, or if we run out of time, I think there's a break after this so we can talk in the hallway. This is a good time to mention. We are here talking about what worked for us. I'm not an attorney. Tanya is an attorney, but she isn't your attorney. So this is not legal advice, and shouldn't be interpreted as such. Your firm may have different interpretations, and you should always ask your own counsel, regardless of what you hear from us. So first, establishing a baseline. I assume most people here are from regulated firms, so you're no stranger to the idea of an auditable standard. Does anybody not know what I'm talking about when I say auditable standard? I love this audience. So, basically, for us, the way that we understand that, these are just the rules we set for ourselves. We develop processes and controls to make sure that our actions are consistent with what we said that we would do. And at Fidelity, open source is a standards-governed process. We have an enterprise-level open source software standard that specifies, among other things, that when somebody wants to use open source or source available software, just expanded that this year, we have to figure out which licenses apply. It also says that once the licenses are identified, the OSPO is responsible for evaluating them and then understanding how we're going to comply with them. And with regular open source, this is pretty easy to understand. So setting aside the actual text of a license for a second, the process of figuring out which license applies to a given piece of source code is pretty well understood. Given a chunk of source code, you can hash it, you can diff it, and as long as somebody has a knowledge base of hashes and diffs, from known open source projects, you can figure out where that line of code came from and what license applies to it. Taken together, the effective license on a piece of source code, it's the union of all the licenses that you found, and that's a very simplified description of the process, but it is deterministic. And the good news is, this is a problem you can literally solve with money. You can buy tools that figure this out for you. But
With interpreting licenses, generally speaking, that can be an exercise in subjective interpretation. Everyone in this room could come away with a different assessment, mostly guided by their particular use case, their area of practice, the industry, or even a very specific field. But the good news there is, it can be solved with counsel, which I guess is also technically solving it with money, but that's a different talk. But one of the reasons, especially with the open source licenses, that has made this process relatively easy up until this point is that the open source definition has been widely accepted by software developers and legal counsel. The OSD has remained unchanged since 2007, with the core principles remaining almost identical to the first version published way back in 1997. So this means when we see an OSD compliant license, we already know that the license allows for certain things, such as free distribution, the ability to inspect the source code, it applies to modifications and derivative works, there are no limitations on who can use the software, and it is limited to just that software. This creates a more streamlined approach which allows adherence to a relevant standard, as Brian mentioned, making it easier to develop and maintain an auditable process, which we know in the financial services industry, that can be very important. So, new reasons for sleepless nights. And I'm gonna go on a little bit of an unrelated tangent for a second. I recently heard someone describe the experience of being on the receiving end of a knuckleball pitch. To avoid getting hit, this person was told, do not move and don't try and get out of the way, no matter what you do. However, he tells the story that as he was standing there watching this knuckleball pitch being thrown at him, all he wanted to do was try and move and get out of the way and try and find another way to try and get that hit. So for whatever reason, this kind of reminded me of LLMs and all of the new related licensing issues that we've discovered over the past few years. And we've certainly encountered a different set of terms than what we would normally see in the open source space. There are usage restrictions like limiting the ability to use the model to train another model. There are limitations on monthly users. There are ambiguous limitations, commercial limitations, and in addition, there are new requirements, such as a need to disclose to your users that you use the LLM, and sometimes even attaching license terms. And the list just keeps on growing every day. And that's because, to further complicate things, these licenses can be updated at a moment's notice at any time. It certainly keeps things interesting.
It does.
To make matters a bit more complicated, as most of you know, an AI model is not just a model. There is a lot that is going on underneath the surface. And everything going on underneath there can be very impactful to our interpretation of the applicable license. You have the untrained model, you have training data, you have fine-tuning, a reformatted model, forked and reposted, and the license terms can certainly get a bit confusing and complicated to interpret. But we found, so what did we do? We said don't use LLMs. Seems simple. No, I'm kidding. We did not do that. For those of you that were at Kelsey's keynote speech on yesterday, who heard him say, compliance, no. That sort of ties into that. But no, we did not say, let's not use LLMs. What we decided to do was we realized we couldn't just attempt to get out of the way of that knuckleball that was heading towards us. We had to stay there and do our best to try and get a hit. We had to figure out how we could best advise our associates on what we could and couldn't, or I should say, should and shouldn't do. For us, even though LLMs are more than source code, and technically not open source, it made sense, at least in our minds, to adapt the review process that we already had in place with our OSPO and expand that to include a review of all of the relevant licenses, like the content licenses, database licenses, acceptable use policies, and all other new types of licenses that have brought into this field.
So one of the better choices that we made, just kind of looking back and just introspecting over the past few years here, we decided that the same people who are evaluating open source licenses should probably also be evaluating the LLM licenses. It is outside of the scope of the original scope of the OSPO. My particular mandate was open source licenses, OSI approved, et cetera. And just in consulting with the legal team, one of the questions that we asked was who else would be able to do this? And we said, well, guess it's probably us. But what this gives us is some consistency. And so I'll give you some examples. The process, without getting too far down into the weeds, before we adapted our process for LLMs, when I analyzed a license, I was looking for a few things. Is the license OSI approved? Do we need to update our documentation to include copyright attributions in the text? Do we need to provide a written offer? Does the license permit dynamic linking? Does network access count as distribution? And for all the reasons that Tanya mentioned, we, of course, preferred the OSI-approved licenses because they throw less curveballs at us. They can't have things like usage restrictions. But to be clear, this list is not comprehensive. These are just examples, and you expand and change it as you go through and read licenses and understand what is important to your company. What's important to you is not the same as what's going to be important to me, so don't take this as advice. But it was during these readings when we started to get questions about LLMs and can I use this particular model that doesn't have a license on it that we've seen before, we realized that we needed to expand our evaluation process. Examples of things that we had to add because of responsible AI licenses, for example. Is there a non-commercial restriction and does it apply to us? Do we need to update our public-facing terms of service in order to use something? There are quite a few models that require you to do that. Are there specific tasks we can't ask this model to do? Is there a user cap? Do I have to disclose that the results are machine generated? These are all different types of questions that we found ourselves having to ask because these aren't typical things you would find in a capital O open source license. The single biggest learning was that it was worth the time to create a license data structure that can configure questions with true or false values, where you basically can read through a license, answer a list of questions, and then I store this in our architecture management tool so that at any given point, I can run a query and I can ask which licenses use a network definition of distribution, which licenses require a written offer. This allows you to set consistent policies when you start looking at your SCA tools and things like that.
And all of Brian's work has certainly paid off. While he and I may be very close to all of this and have an understanding of the potential impact and the various risk points, we really had to come up with a way to easily to communicate this information in a way that worked for our associates. When creating a summary, we had to try and keep it as simple as we possibly could, because this is an easy reference point. Of course, we do have sort of the larger description going on behind the scenes for those that have an interest in reading that. But this was the way that we chose to actually present this to our associates. And ultimately, it's been a bit more work, which Brian does most of it, but to determine not only what license applies, but what other licenses also apply. Once those are identified, we need to figure out how everything works together. This is not unlike, sort of the current process when distributing software. You need to know which open source licenses are incompatible and take steps to remain compliant. In order to do this, we implemented a few different steps, which I think, Brian, you can speak to.
I can. So I'll talk a little bit about process and tooling here. Historically, if you have a well-configured SCA tool, it's pretty easy to figure out which licenses apply to any given piece of open source software. So as I mentioned earlier, you have diffable and hashable source code. You can figure out the license on a project, or if somebody copied and pasted code from another project. There are vendors that have comprehensive knowledge bases that map these projects back to their licenses. And then the third piece, if you combine the output from the tool with what we were just talking about, the different characteristics and the questions that we ask in the data structure, you now can have a pretty comprehensive understanding of where and how you can use this source code according to what your firm cares about. This is fundamentally a horizontally shaped problem. So assuming that the licenses are correctly declared and identified, you'll be checking a specific version of code, which has specific dependencies, which carries specific licenses, which you're either comfortable with or not. And assuming that the license info is correct, that's kind of a fundamental assumption here, you don't really care about past versions, just the version that you're distributing. And unfortunately, LLMs kind of toss a wrench into this. Remember, earlier we said that, Tanya, you said the only thing anybody cares about are pre-trained models. Like, let's be honest here. If it doesn't have the weights, it's not particularly useful unless you're training your own models, and that is a small subset of firms. Weights, or the pre-training data, they're the reason that pre-trained LLMs are so large, and they are basically massive arrays of numbers that, one, we can't explain, and two, get reshuffled every time you retrain the model, and this happens in unpredictable ways. So obviously, if you're looking at different generations of an LLM, you can detect that something has changed. That's easy. Like, you just look for different numbers. And if somebody has a knowledge base mapping each specific version of these numbers against that model, you can tell when you're seeing something that's already been fingerprinted. But to date, I've not seen anything that can credibly and programmatically predict how a pre-trained model will change once it's been fine-tuned, when it goes from one state to another. Due to the nature of the training process, you can run the exact same training operation twice and get radically different numbers. In other words, software composition analysis, SCA tools, on a newly trained LLM simply failed. It's just a fact of the matter. I'm not saying anything bad about SCA tools here. It's just there's no programmatic way to predict how you're going to get from one state to another. So in essence, we're back to the bad old days of open source person standing in front of an audience complaining about binary distributions and But this time, unfortunately, we don't have the ability to do things like decompile them and all those other things we used to do. So where's this a problem? Let's say you're using an LLM from a site that allows user-uploaded models. Models may go through any number of revisions prior to being published under someone's account. They can involve any number of training data sets from literally anywhere. Can include input from other models, and these things can alter the model, reshuffle those numbers any number of times. When this happens, there's currently no paper trail. The weights are just reshuffled, meaning we can't deterministically say this state led to that state, then to that other state. And there have been some really good talks over the years about the relationships of open source licenses to weights. I'm not going to get into any of those here and down into those. I think they're very fascinating weeds. But I'll just note that some of these things can have license obligations that survive fine-tuning. In the end, the license declaration in your LLM's model card that you find on this site where you download the user-posted models will always and only come from the user who uploaded the model. If the person who uploaded the model was sloppy about determining which license applies to that model, or misinformed, or even malicious, you have no way to tell if the license declaration on that model is complete or correct. It does not take much time, if you go onto some of the more popular sites, to find models that are listed as MIT or CC by SA, and then you go read the description in the model card, and it is clearly fine-tuned from something that's a lot more restrictive that does have rolling thunder license obligations. And this is probably the fourth time we've said it, but this really matters when models and data sets don't use those traditional open source licenses. Some of these licenses that you'll find, they explicitly forbid improving other models. Some data sets prohibit their use in training. Some of them explicitly state you can't use them in a commercial context, and their provisions are going to carry forward through multiple generations of fine-tuning. And if you remember, I said that source code licenses are a horizontally shaped problem. Now we have to worry about another dimension, how licenses carry forward through different generations, as well as another dimension, what other software you're allowed to use the model with. Because, again, license considerations that carry forward. So the bad news for the foreseeable future is that determining license obligations is going to require manual work. First to figure out what was the list of ingredients that went into the current version of the LLM, and second, figuring out what licenses those ingredients themselves drag into the mix. So the best thing we did here, just kind of getting back to the core of this talk, best thing we did here was to treat models as you would a family tree. So if you've ever built a family tree, it usually goes, means going to your family members and asking how far back do you remember who's related to who, and then you go find others and you ask the same, and you may cross-check with some others, and you work your way backwards in one generation at a time until you run into a gorilla or run out of living relatives. and you can do the same with many LLMs. Sometimes you can tell from the model cards where they say, my model was fine-tuned from this other base model. And then you go check out the model card for that base model, and it says, this model was fine-tuned on, or was trained on these 3 data sets. And here's a link to the untrained model. And once you find these ancestors, you can get back to the point where you are, assembling a list of the different licenses and determine if any of those licenses survive fine-tuning. From there, you can figure out if it applies to you. And ultimately, you're going to build up a list of licenses that you think govern this particular generation of this particular LLM, and then figure out from there what your obligations are. This sounds like a lot of work, and it is. But one of the things that you'll find is that there are really only a handful of foundational trained models out there. It's not a perfect assumption, because models do change. But for the most part, if you figured out the ancestry of this particular version of Google's T5 large model, you probably don't need to repeat the analysis when you find another model fine-tuned from that model. You just need to link to your previous analysis. So within Fidelity, we do have an architecture tool. It allows us to designate predecessor and successor relationships between pieces of software. And so when I find something new, when somebody asks to use an LLM that we haven't reviewed before, if I find something I've already reviewed, I just link the two, and I don't have to repeat this analysis every single time. That's been incredibly valuable, and then at the same time, we've also built a tool which will dynamically calculate the license obligations on a given LLM. I call it the worst case scenario calculation based upon the licenses that we identify. We've been using this process for about 9 months now, and I can tell you firsthand that it has a very high warm-up cost. But we went into it assuming there wouldn't be that many new models, and we were correct. It turns out when people ask to use things now, they're often derivatives of something we've already seen, and the overall cost in terms of time is reasonably low. So pulling this all together, we have come a long way from scan the source code and match the hash to an upstream project. While SCA is still absolute table stakes for an open source compliance program, we have had to evolve quite a bit because of LLMs and the different license characteristics that we've seen. First, we had to get really organized about how we're reviewing and classifying licenses, as the new so-called open licenses can actually be fairly invasive. Second, the shape of compliance has changed from being a lateral, what are the licenses that apply on this specific version of software that I'm building into this specific application, to this multi-dimensional, what non-obvious licenses in the history of my project have some impact on what I can do. And it's been an interesting time. Just kind of close by saying that the irony here is that the tools to do this analysis, when we do eventually get to the point of being able to pay somebody to do this analysis for us, they're probably going to be LLMs themselves. They can read the model cards and white papers faster than any human can. So it's a problem that we'll probably end up solving itself.
Yes, yeah.
And then Tanya and I can move on to other things.
Exactly.
So, but exciting space. So that's everything that we have.
Yeah. Excellent. Thank you.
Thank you. Point well taken. This is fundamentally a data problem. This is not a code problem. This is not a policy problem. This is a data problem of assembling facts. To date, I haven't seen an effort to do this in the public, but it would be, there's ripe opportunity here. Sure. Without naming names of the specific tools, because I'm not allowed to do that, we start with a tool that allows us to put in facts about a specific piece of software. Those specific facts about that specific piece of software, we can establish the relationships between them and say, this is a predecessor of that one, this is a predecessor of that one, one-to-many relationships. The way that we handle this is that if we evaluate a model and determine that it has three predecessors underneath it, and each one of those has two predecessors underneath it, each one of those is an individual sheet, which are then linked as, this is a successor of this is a successor of that. And that's just the facts about the specific model component itself. Separately, I was talking about the license data structures. For each one of those components where we've listed facts about the software, I attach in the license that applies to this. And I've already gone through that analysis of this license carries forward through fine-tuning or it does not, through multiple generations. What we do is we then kind of assemble together. It's like pulling cards out of a deck. Like we assemble together the licenses that we think apply to this particular version of this particular model, spread them out on the table, and figure out what's the worst case scenario across these. If one of these has a non-commercial use restriction, everything is non-commercial, right? So it involves a lot of internal development. We don't have a tool that we bought off the shelf. We built this internally, and this is a tier 1 part of our architecture management tool. But it does allow us to dynamically handle a couple of interesting situations, like what happens if we change our mind about a license that we thought was okay 6 months ago? We want to update that in one place, and anything that either goes green or goes red as a result should do so immediately. So it allows us to scale up fairly large because we can handle the facts about the license separately from the facts about the model. The second thing is that as we learn more about models, like for example, if we find out some model had a data set that we didn't realize was in there that we now have a problem with, we can update that on a moment's notice, and anything that uses this data set effectively has to, we have to update the disposition and say you can't do it. And we make sure that we're consistent with the guidance that we're giving out, with one-click changes. So that has been the main thing. We realized this problem was going to expand and continue expanding over time.
Yeah.
Thank you. Sure.
Which is why it was very worthwhile to put in so much work at the very beginning. So kudos to you on that, because that's the the foundation of it all.
I
really
appreciate
makes
that.
a big difference.
I appreciate that, but the legal work that went into this, a big part of this, I will say that our legal team has been very receptive to the idea that some of these licenses are things that nobody really has an answer on yet. And we've worked very closely together to figure out how to get to a place where we're comfortable not just saying, don't do it, don't use LLM.
Is the tool called M-Models 23andMe?
No.
I don't have a question. Based on what you said, I almost have these software.
It is a difficult problem in the sense it goes back to that non-deterministic changes when you retrain a model. If I pay a vendor to fingerprint models for me and they pick up a different fingerprint and somebody has retrained the model using the exact same data, we're going to see them as two different things. So it becomes incredibly inefficient to track all possible outcomes of all possible models. So we just have to figure out different ways. I mean, it goes back to just figuring out facts based upon what you can track back in the lineage. So I'll give you a practice. I'm not sure if it's the best practice. So we go with as much information as we can reasonably find. So the process, I found one model. I'm not going to maybe name specific names here, but there was one model which was listed as MIT. And reading through the model card, it said, this is fine-tuned from another model. Going back to that other model, it turns out it had a research license on it that said you have to buy, you can use this for evaluation, but you have to buy a license from major provider if you want to actually use this. It was all manual. I mean, and if the person who published the model that was licensed as MIT hadn't written that we fine-tuned this from this model, we would have never known. But the fact that we could tell meant that we kind of needed to act on it, right? It's like, ignorance is bliss in many ways. But we were no longer ignorant, so at that point then, the way our calculation goes internally is that this more restrictive research license overrides MIT. So you have the declared license and you have the effective license. The effective license overwrote the declared license.
I would expect.
Tanya, how do we feel about custom licenses?
Right. I have no comment.
Custom licenses are difficult.
Yeah.
And
yes.
Yeah. One of the things maybe you can comment on is how often do we have to go back and recheck to make sure licenses haven't changed?
Yeah, that's an excellent question.
I mean,
because they do change.
They do.
Sometimes every couple weeks, sometimes overnight.
Yes.
So yes, and then having to determine what the best cadence is to check in and see if those licenses have changed since you last reviewed them and what those implications may be.
Yeah.
So
our goal is not to scare you. I will say we delivered a lot of bad news over the past half an hour. Our goal is not to scare you, but we do. Our intention in submitting this talk was to at least lay out some of these issues that we've seen, because this has changed. I mean, this is a different landscape than it was 2 years ago. These are issues that were latent, that were going to come up eventually, but at this point, kind of, the answer can't be no.
Right.
Like, we've got to figure out a way how to say yes, and here's the risk,
right.
and move on. So, any other questions? Sure.
So maybe building on the language,
Mhm.
how do you imagine the top-down geographical approach? Not the license itself, but one given geography saying, maybe
Yeah.
I'm getting into a big thing here, or case law that changes that effect. Are you thinking on applying that in your framework, or that's a different dimension?
Can you take that one?
Yeah, I would say that's well,
Sorry.
Yeah.
So in terms of jurisdictions, that's an ask your attorney question. I mean, and that's not specific to LLMs. That's specific to any type of legal question. All I can really tell you is that we built the framework to adapt for that in terms of our internal data representation of these licenses and the LLMs around them, such that if Tanya gives me a call and says, hey, like pull the plug on this particular one because we now have concerns that emerged overnight, we can do that, and because it's part of our architecture management tool, we communicate it out to the firm instantly. So that's the best answer I can give you without getting into interpretation. Just be ready for changes in interpretation.
How do you manage that?
Oh, that's a good question.
that'll be the talk next year.
Yeah, well, it might actually be. I didn't get into this, and like, wasn't part of Tanya's part of the talk either. One of the challenges that we found with LLMs is they tend to evade SCA tools. If you're using a certain popular Python library that starts with T and rhymes with transformers, it pulls in models at runtime, which evades any build time scanning. Yeah, so there are questions. It's going to have to be some level of governance that's beyond this, like blocking at the firewall. There are certain products I'm not going to name vendor products, but there's certain products that claim to provide some governance for proxying what you're allowed to use. So it's going to require a tight integration between, obviously, legal and the interpretation of the licenses, whoever's doing the digging to figure out which licenses apply. On the SCA side, being able to identify the licenses that you can, and then on the, on the firewall side, blocking the things that are going to be problems. So. Unfortunately, it's going to be a multi-dimensional solution to a difficult problem, and there's probably not any perfect solution to it either. All right.
Great. Yeah, thank you.